scenarios will be off. There you go.
Hello, everyone. Sorry for the delay. Zoom has a mind of its own today. We'll give a couple minutes for people to come in. My name is Sue Chrysler. I'm with the Texas A&M Transportation Institute, and I'm an Associate Director of the Safety University Transportation Center. We appreciate you joining our webinar today. You've all come into the meeting muted and with your cameras disabled, and if you have questions during the presentation, please use the Q&A option or the chat feature at the bottom of the Zoom window. We will address these questions either during the presentation or during the Q&A section. If you'd rather ask your question yourself, we highly encourage that and just ask that you please raise your hand or let me know via chat, and I'll unmute your mic and video during the Q&A so you can discuss items with the presenters. We encourage this conversation. There will be a few discussion points raised during the presentation, so if you feel comfortable to do so, please just raise your hand and we'll unmute you. So at this time, I want to introduce our presenters today. Tara Goddard is an assistant professor in the Department of Landscape Architecture and Urban Planning at Texas A&M University. After earning a master's degree in civil engineering from UC Davis, she worked as an associate transportation planner for the city of Sacramento and then served as the bicycle pedestrian program coordinator for the city of Davis from 2007 to 2011. She then earned her Ph.D. in urban studies at Portland State University. Dr. Goddard's research focuses on creating a just transportation system through safe roadway design and inclusive transportation planning. She's known internationally for her expertise on reducing traffic deaths and injuries, particularly for pedestrians, bicyclists, and other vulnerable road users. Her work on roadway safety culture and for studies examining racial and gender bias in transportation safety. Dr. Goddard studies both individual transportation behaviors and socio-technical systems in which they occur and uses quantitative and qualitative methods. Her recent research explored the current state of marketing, availability, and crashes involving advanced driver assistance systems and how practitioners and decision makers are wrestling with the rapid influx of technology in transportation. Our second speaker is Rebecca Sanders, who is the founder and principal investigators of Safe Streets Research and Consulting, LLC. She has 16 years of academic and consulting experience analyzing and addressing pedestrian, bicyclist, e-scooter, and motorist safety, behavior, and mobility through crash analysis, survey research, and design. Her current research focuses on pedestrian safety in darkness and pedestrian fatality hotspots, safe practices for e-scooter use, and national guidance for bicycle facility design, as well as systemic safety analysis and guidance related to pedestrian bicyclists and principles and guidance for roadway reallocation. As the chair of the TRB Bicycle Committee and the co-chair of Portland's Pedestrian Advisory Committee, she works with people across the country and locally to improve safety, mobility, and transportation equity for people walking, bicycling, and scooting. During her career, she has helped cities and counties across the country understand and address multimodal safety through Vision Zero and systemic safety efforts. Dr. Sanders is located in Portland, Oregon. So at this time, I'm going to turn it over to Dr. Goddard.
Yeah, thank you, everybody. Thanks for joining us this afternoon or whatever time it is where you are. Really looking forward to getting to share this project that we worked on and the conceptual model that came out of that work, and also hoping to engage in some discussion with you all about the conceptual model and where we go from here. So, making sure. I'd like to start by telling you how this project got started. Sometimes we never really talk about how these things get going. So I've been, interested in studying different aspects of kind of partial autonomy and vulnerable road user safety. I gave a talk back at UC Davis back in 2019, but I'd never really experienced for myself what it was like in, say, looking for purchasing some of these technologies. And in a little bit, I'll come back to actually defining advanced driver assistance systems. But I wanted to start with this. So that's a picture of me with a truck and camper that I got during the early times of COVID, like many people looking to get out and explore. And it was in the course of looking for a vehicle to do that, I really realized how difficult it was to buy vehicles with certain safety features. You know, I'm maybe a special user case in particular, very, very safety oriented. I wanted particular things to help me drive safely with a camper, but I found that most people who helped me could tell me a lot more about the number of cup holders or the colors that a vehicle was, you know, available in versus safety features. And then when I went looking even more deeply, even for like window stickers, the Mulroney sticker, for those of you who know, I couldn't even find that information. So I became kind of interested in this, you know, first personally and then as a researcher, and realized that there's a lot of research, or there is and has been a lot of research going on in these system safety technologies. When the drivers are using them, do they trust them? Do they turn them on and off? Things like that. But there was a real gap, it seemed like, in understanding how these technologies even get marketed, sold, packaged, and end up in our hands in the first place. And then also exploring that a little further and seeing that there was gaps in what we collect after the fact. If there is a crash, does the vehicle have these systems? You know, did they help, et cetera? So that's how this came about. So really resulted in 3 overarching research questions. How are automakers, you know, kind of, like I said, marketing, selling, packaging these systems? How effective are they in either preventing crashes or at least mitigating the severity of crashes? Do they change the crash type likelihood? And then how are data collected to even help us understand that? So an opportunity came up to go for one of these safety research grants through this University Transportation Center. I just want to give a big shout out and thanks to my co-PI, Rebecca Sanders, who you'll also be hearing from, and then also Dr. Tony McDonald, who was on the project the first year and then left A&M and left the project, but he was essentially involved early on. And then we were able to support with the grant multiple students, PhD, master, and undergrad, which was really incredible. So I want to thank them for their work on this. The Aggie Research Program, which supports undergraduates who are really interested in getting involved in research, and the DeBakey Executive Research Leadership Program. And of course, Dr. Sue Chrysler and Elisa Kuhler at Texas A&M were a big part of helping us with the administration. And I did put the project website on there briefly. You'll see it again later. It'll be available where you can get the multiple publications that have come out of this work, policy, graphical briefs that we made, things like that. Okay, so stepping back to talk about some definitions. You have probably seen some version of this graph, SAEs, levels of automation. And you know, some people will refer to this the spectrum of the eyes off, hands off, mind off, as things get more automated. But in particular, what we're going to be talking about is what's, you know, under the very big umbrella of advanced driver assistance systems, or ADAS, as I'll refer to it through most of the presentation from here on. So everything from very passive systems that are just kind of a you know, maybe an audio alert or a blinking light, to things that actually, you know, intervene or work with the driver, or things that are preemptive before the driver does anything. And I just want to point out, I think it's interesting, if you notice above level 3, there's actually a gap, at least on this graphic, between what's considered a driver support and an automated. So level 3 is in this interesting zone where I think we're still wrestling with a lot of these. And as we'll see, you know, consumers are going to be wrestling with a lot of these. What does it do? What doesn't it do? So these are the systems we'll be talking about today. So again, ADAS, that has a variety of features. There could be cameras, sensors, and of course we need to remember the algorithms that are making some of these decisions, right? And the more complex and the more automated or autonomous these technologies are, the bigger the importance of algorithms. I just want to put that out. And there's passive versus active functions. And an important piece is there's features that you have to opt in, you have to actively go into your system to turn on, versus ones that can opt out, and then some that are on all the time. So just a list, many of you are probably familiar if you've driven a vehicle that's been made in the last, I'm not sure, 10-ish years. Cruise control, like adaptive cruise control, adaptive braking, blind spot detection, etc. And I mean, there's multiple limitations. Here's just a few that you may be familiar with. So varying levels of efficacy. So are they useful, but in what context? How effective are they? How much do they rely on driver intervention or not? there's questions and research into this idea of, risk homeostasis. So do we basically just start to over trust it and check out mentally even more than we should? Many of the technologies do seem to be optional, or even if you can have to opt out, it is very easy to turn them off. People get annoyed with hearing the sound or whatever, and they turn it off. So then, of course, they're not going to be effective at all. And then there's just a lot of confusion potentially about how these work and whether it's valuable. So thinking about why we should care about ADAS, certainly with the new National Roadway Safety Strategy and larger issues of looking at safe systems or Vision Zero approaches, safer vehicles are a core piece of that. And really importantly, these technologies are here now. They're deployed all through the fleets. Things are changing. New technologies are being advertised and launched all the time. If you watched any Super Bowl commercials, you've probably seen that. But we have to keep asking, how effective are they? Are they even available to everyone? Which I'll talk about things like pricing. How easy are they to use and how easy are they to opt out of? And this I kind of raise as a question. You've all probably seen some version of these diagrams of, at least in the US, or particularly here, our vehicles getting bigger, kind of more insulated, safer often for the people inside the vehicle, but less so for the people outside the vehicle. So as we've done that, are we kind of asking or creating the need for more and more sensors as well? So ADAS is being asked to fill that role. And there is great information out there about what these technologies do, but it does require someone to actively go looking for it and watch videos and get trained for the most part. So My Car Does What, which Dr. Chrysler and others were instrumental in putting together, has really fantastic resources. If you haven't seen it, you should check it out. But again, it really puts the onus on individuals to go looking for this. And so even on the website, it says, read your car manual or ask your dealer how a specific system works. These systems are not standard. They vary from model to model. And so other research, there's some great research that came out of Australia, looking at kind of the insufficiency of, car manuals and a lot of the, not enough training for people at car dealerships, and plus they have high turnover and a lot of challenges that, again, if they're not set in the vehicle, they really put a lot of the burden on individuals. So the first thing that we looked at to explore that was this issue of selling and buying of ADAS. So we looked at the top selling models for the largest US, European, and Asian automakers. And we focused on 3 technologies in particular, just partly because they're some of the most common. So forward collision warning, blind spot detection, and automatic or emergency braking. And we looked at what was available by not only each model, but the different trim levels, what were the costs generally, what were they named, so what even people might think they do. And then we also looked at how hard it was to find that information. And these findings, these are published in a paper that we have on transport findings, but we found a lot of variety in the naming. It can be very confusing or over-promising. Marketing, so looking at ads and the things that the way that the technology intervenes that might not be very real world accurate. We found in particular that ADAS is often grouped or lumped these technologies with convenience features or luxury rather than as a safety. And so people have to be able to afford or choose to pay for more expensive trims, which really becomes, a safety equity issue. And then training, the demonstration, other literature has shown that demonstration during test drives or vehicle handoff is pretty minimal and probably insufficient. And then we looked at the special case of online marketing. And this is really important because there's an increasing share of the vehicle fleet that is being purchased via online sellers. And it's one of the kind of selling points, no pun intended, of that, or the way they really push that, is that what I call a hands-off handoff. So it's attractive that people don't want to have a high pressure sales conversation or situation. A lot of these are still delivery, but there's minimal interaction. But then you see some of these like car vending machines, like the one I have there, and this is directly from the Carvana blog. So these increasing challenges of where do we intervene and get consumers information. And then also, again, looking at this online, is we charted out how people even find the information. How many steps does it take? Where do they have to dig through? Do you have to do keyword searches, etc.? And I know this is a small table, so you can't take it all in now, but again, we've published this work. And really seeing that, again, it takes a very motivated buyer, and even a very motivated buyer can sometimes not find the information because it can vary literally vehicle by vehicle. So even if a model and trim might have those features, you actually have to go and look at the vehicle, and that with the online selling, that's often not something you do before you at least put your money down. Okay, so that's kind of the quick taste of some of the selling and buying work we did. I'm going to shift to the other end, the other bookend, and looking at post-crash data collection. So getting to this question of how do we know, what we know? And so we first wanted to look at, well, what gets recorded in police crash report forms? And if you don't know, there's guidance from the manual on uniform crash criteria, but it's guidance. And so every state or territory has its own form, so they're not standardized across. But we pulled all of those and we looked for where would an officer report, was there a technology, was there an automated technology, we were very broad in looking for where would this be other than just the narrative, and found very few that even had any space that has caught up with these technologies being deployed. So there's really, there's a potential data source that we're missing for immediate on scene to understand about whether these technologies were they engaged, etc. It could provide a really rich data source, but then there's also privacy concerns and the issue of the Fourth Amendment, which prevents officers from, say, just plugging in something and reading the car's quote unquote black box to understand what was going on. So those are challenges to view it as a potential data collection. I will say that literally just in the last couple weeks, there was an update to the manual on uniform crash criteria. And so that was not reviewed as part of this project. We have not been able to look at that before doing this presentation. So I'm hoping there's more in there about technology, but I can't respond to that. So if anybody is here from NHTSA or otherwise that wants to jump in later, we'd love to hear that. That's fine. Okay, so now to talk about safety outcomes and that part of the research, I'm going to hand it over to Rebecca.
Thank you, Tara. So another aspect of this project, if you all are getting the picture, this is a multi-methods, multi-phase project, was to try to understand what we could determine about real life safety outcomes. So we've seen that these ADAS features have a lot of promise in the field, in the lab, and certainly, under controlled conditions, they perform really well. But as Dr. Goddard mentioned, these are often turned off, or people don't understand how to use them, or just quite frankly, you can't afford a model with that more luxury package, and so you don't have them. So we wanted to see what we could determine from real life crash outcomes by looking at a data source that actually had this information. As Dr. Goddard mentioned, a lot of the crash data don't have this. So to do this, well, just to say this part of the project was our aims were twofold: to understand the relationship between the presence and type of certain ADAS features and crash outcomes, like I just said, and then also to really develop that initial understanding of the promise and limitations of SIS data in particular, and I'll describe that in a minute, with regard to understanding this problem. So if you go to the next slide, the data source that we used was from NHTSA, and it was the Crash Investigation Sampling System, CIS, C-I-S-S. And the reason we use that data source is that that data source in particular involves additional investigation on the part of a team, more or less, to really dig into the crashes that are selected. This is a sample of crashes, and try to understand, okay, were ADAS features there? Were they turned on? What else was going on? And this is the only data source that we felt like really could give us any insight at all into real life crash outcomes. We looked at the three features of interest if you go back, blind spot detection, forward collision systems, and lane keeping systems. As you all probably know, there are a lot of different ADAS features, but these are ones that I think Dr. Goddard mentioned are more prevalent. And so we felt like this would be a good way for us to start this investigation. Because this is a sample and there aren't that many, particularly because these crash features have these ADAS features have been in increasing prevalence in our fleet, and because all crash data are made available with a lag, We kept our analysis to descriptive statistics and bivariate statistics, really just trying to get like a floor of understanding so that we could build on that for future research when the data source would be larger, more robust. So some of the limitations, as I've just mentioned, are that we have a small sample size and also that there's co-occurrence of these ADAS features. So it was really hard to investigate any one of these in isolation, because often when you have blind spot detection, you also have forward collision warning and you also have lane keeping. So the way that we handled this in this study was to just have a binary yes, no ADAS variable. So if you had any one of those, the ADAS variable was yes. And if you didn't have any of them, it was no. And then everything we looked at was really in a, aside from the descriptives, was really in a bivariate fashion to try to understand, okay, what relationships are there? We did use chi-squared statistics and t-tests and other measures of analysis where appropriate to try to get a statistically significant understanding. But just note that the sample size was small and that affected our analysis. So if you go to the next slide, we have a few key findings from this. One is that we did find some evidence that vehicles with ADAS are less likely to be involved in severe crashes. So as I mentioned, CIS is a sample and it's geographically weighted, and a key aspect of it is that they are trying to give us information about the year of the model, because we also know as ADAS features have come onto the market, other crash likelihood and related features are happening on all vehicles. So we know that if you have a vehicle from 1990 and you have a vehicle from 2020 and there are no ADAS features on the 2020 vehicle, you're still more likely to survive a crash in a 2020 vehicle, right? So there's improvements in crash likelihood and crash severity that are happening irrespective of ADAS. So it's really important to try to control for that vehicle year, else we may be ascribing some kind of result to ADAS features that may just be a result of every vehicle has gotten better in that time. So controlling for that year, and we weren't able to do that in a really detailed way for a few reasons. Again, number one, the sample size was small, and number two, we didn't actually have that level of detailed information. So if you look at this figure here on the right, for example, you see, and it's very small print, so I'll just read it to you. The magenta represents all vehicles that were involved age 2009 or earlier. And then all the bright green represents that there was one or more vehicle from 2010 involved, but neither of the vehicles had an ADAS feature. And then the blue represents crashes that had one or more vehicle from 2010 involved, and at least one of those vehicles had ADAS. And those distinctions were made based on the CIS data set. So those were the years, sort of the break points that we had, 2009 and earlier, 2010 and forward. And what you can see is that this figure represents the percentage of crashes resulting in a KSI, so a fatality or a serious injury, by vehicle age, controlling for it in that very sort of blunt way. The presence of ADAS, as I mentioned, and then also body type. So specifically, this is 2 autos. And that's important because we also know that if you have an auto that crashes with an SUV, the crash likelihood is going to be, in favor of the SUV and against the auto. Same thing for a truck. We did this also for SUVs and for trucks, but the sample sizes for those were so small that we didn't feel like we could really say anything about those results. But what we do have here is a mild statistically significant result for when you have 2 autos or 2 sedans, that when at least one of them has an ADAS feature, they're less likely to result, the crash was less likely to result in a fatal or serious injury. The second finding we have on the slide is that crash severity appears to have been affected by the presence of ADAS. So ADAS mitigated speed differential in crashes, potentially reducing crash severity. Now, the reason we have potential there for crash severity is that what we're looking at there is the delta V. So basically, what was the speed of the car when the ADAS feature was activated versus the impact speed, so when the collision occurred. And what we could see from the data is that there appears to be an effect, if there is an ADAS feature involved, that the delta V, or the differential between those 2 speeds, is lower, which means that if you have lower speed, you have less kinetic energy transfer. And this is controlled for in sort of an ordinal way. So the speed to begin with was lower. So an ADAS feature engaged and slowed the vehicle, it appears. And then the collision speed the impact speed was lower. So I'm using words like appear here because these results were again, small sample, less, statistical significance was more like in the 95% range, not 99.9, like me might want, but it's promising, and yet more research is needed. I think I got a message about any kind of clarifying questions I think we could take now, Tara, but let's wait and do any other questions afterward. Just to get through our last couple of safety findings. So we also looked at crash types, and what we found was that vehicles with ADAS features were less likely to be involved in rear end and head-on collisions than crashes that did not involve a vehicle with an ADAS feature. So rear ends and head-ons, okay. We actually saw that vehicles with ADAS features were slightly more likely to be involved in angle crashes. But when an angle crash occurred, vehicles with ADAS features were less likely to result in a death or serious injury. So we don't know exactly what's going on there. It could just be that because of the distribution of crashes, if you have a lower likelihood of head-on and rear end, you still have those crashes that, even if an ADAS feature is involved, that crash set has to go somewhere, right? Those crashes go somewhere. So it appears that they've gone to angle crashes, but when the angle crashes occur, they are less likely to result in a severe injury when an ADAS feature is involved. So again, these results are, we're sort of building the evidence base that in real life, it looks like there are real world impacts, but they're small, and we need a larger sample size ultimately to be able to further investigate this and draw stronger conclusions. So if we go to the next slide, I mentioned earlier, and I've said several times now, small sample size. There are some other limitations to these data. So one is that there was no information on the effects of these features in terms of crashes with non-occupants. So we absolutely need more robust data to understand and determine what and how ADAS features can increase or not the safety of people walking, bicycling, and otherwise outside of the vehicle. Currently, that exploration is pretty much impossible in the data. And in general, we just need more data. We need a larger sample, a broader sample with more years to be able to really investigate this problem. Next. And so our sort of broad conclusions are that we do see hints of beneficial safety effects of these 3 ADAS features in crash data, but we do have those caveats, as I sort of said a few minutes ago, with each one of those findings, right? The technology is promising, but we absolutely need more data and research in real life conditions. And I think our overall conclusion is that, there's a lot of talk about safer vehicles. There's a lot of talk, I think, among enthusiasts in particular about the role of technology and how technology is really going to solve all of our problems. And, who could argue with getting all humans out from behind the wheel and giving everything to a computer? And I think, there are lots of arguments that we could have there. And also there is a lot of potential and there is a lot of promise. But overall, safer vehicles are just one part of this strategy, and that redundancy is critical. It's key to a safe system approach, that we're not relying on just one aspect of safety to get to where we need to go. We absolutely need safer roads. We absolutely need safer speeds. We need safer human behaviors, and we need better post-crash care. Safer vehicles are key, but we can't rely on this to solve all of our problems.
Okay, great. Thank you, Rebecca. Laura, did you have a clarifying question before we moved on? I just want to give you the opportunity. We may need to just have you put it in the chat and then.
Laura, you should be able to unmute if you want to ask your question. Or not. I will add that one of our audience members put a note in saying that she had reviewed the new crash criteria handbook, MOOC, and there is no guidance in there. In fact, ADAS isn't even defined in the new version. So things doesn't sound like things have changed much on that front.
Okay, well, we need to concentrate on getting what we found in our work and recommendations over to them for hopefully the next update. Laura,
And actually, Tara, I'm sorry.
Go ahead.
I was just going to say on that point, just to remind or to let folks know, this work that I've just presented, and I should acknowledge that both Tara and I worked on this, but actually the research was led by my partner, Dr. Jessica Schoner. So she gets a lot of credit for this work. And this is a publication that's out through TRR, Transportation Research Record. So if you want to know more about what we found in this study, there is a publication that's available.
Thank you. And my huge embarrassed apologies to Jessica for leaving her name off of this. Okay, so we'll get to the questions in the Q&A at the end. So I'm going to just keep going for now. So I just want to that's a good segue. So just kind of the key findings over, this has obviously been a very quick overview of a 2-year project with a lot of moving parts. But overall, kind of the key findings is, there's just this wide variety of these technologies that are all kind of under this umbrella. And some of them are more on the convenience side, some of them are more on the safety side. But they really vary widely in their design, their naming, their pricing, where they're available. One thing I didn't touch on earlier is that some of these safety technologies were actually harder to find on bigger vehicles, which is probably the vehicles that need them the most potentially, and how they function. And they're really, from the research standpoint, they are being developed and deployed, for public use way faster than we can even keep up on the research side. So we really need to be, working on this and working with industry partners to really ensure that these are effective and kind of realizing, like Rebecca said, some of these promises of safety. And it's understandable, again, like Rebecca said, about this focus on kind of level 4, level 5 autonomy, but for a lot of reasons, those are further out, and these technologies are here. And so that's where we, as in looking at all the pieces of this, we really felt that we need this holistic view of how these pieces fit together and how that can guide the research going forward. And that's what has come out of this project, is this development of this conceptual model. So it's not easy to explain a whole conceptual model in this kind of format, but this is the full model as we have been publishing it and showing it. So on the, kind of from the upper left and on the left side, we have what I would consider the kind of pre-purchase, before they're in the hands of consumers. So thinking about everything from market forces on vehicles, but then in the black are the ones that we've really studied, and I'll show that in a minute here. And then moving, from left to right, kind of what goes on during ownership, with ownership and use, and then what happens in the case of like when there is a crash, and was ADAS involved, did it help, etc. And so it's a lot to kind of parse, but I'm gonna show a few pieces of it. So our research, the things that we kind of touched on briefly here, really focused on these pieces. So the marketing, the selling, like the pricing and availability, and then the online versus in person. And on the other side of things, the work that Dr. Sanders just presented on some of the crash involvement, severity, etc. And then there is, like I've mentioned, there is existing and ongoing research on other pieces of this as well. So in particular, a lot on the driver behavior, thinking about things of what's called driver takeover. So when the system can't anymore, or detects a situation scenario where it says like you need to take it back, what happens? So there's great research going on in that area. There's been some research on like purchasing decisions, how people decide, do they talk more to their friends, do they do online research, and then also some, which I mentioned or alluded to before, with looking at driver manuals, or even going in and looking at how people talk about these when they have a potential customer. And then some of the dealership training, although there hasn't been a lot in that area, I think there's a lot of room for more. And something that came out of our work, I think, is really, I'm a researcher, so we always say there's more research to be done in all these areas, but in particular, a couple that could really use more emphasis. So first, I'll say on the right side there, the safety outcomes. Rebecca did a great job of discussing, a lot of the limitations. The SIS database has the potential to do even more, which is great, which we had some recommendations about additional things that could be looked at. But again, it's also a particular sample. So all the different ways that we can figure out how these are being used and how they actually affect safety outcomes is, of course, extremely important. And then a really kind of understudied area, as far as we could tell through our literature reviews and in talking with our fellow scholars in areas like law or policy, is really understanding the role that liability and insurance could play in this. So what would happen, for example, if automakers were more responsible for things when they were misused, or they didn't actually do what the commercials say they're going to do. That's just one example. But in general, how might the insurance industry play a role? And also in some of the data collection that they already do potentially with consumers, as ways to reward people. What could we learn more from that data? And then regulation. What is the role that should be played as far as, say, regulating that some of these systems can't be opted out of, they can't be turned off, or it should be more standardized about how these functions or where to turn them on and off, or even what they're named. So lots of open questions for more research. And again, just to show you the whole model, we really tried to develop something that we were hoping would be a useful guide, so that whatever piece of this someone's interested in or looking at, they might be thinking about how does it fit into the other parts of the whole system as well. So just broadly, I'll just say again, some of the recommendations that came out of this work, I mentioned insurance. Like, is there a way to require or incentivize maybe some of these proven technologies to, increase safety? How might regulations standardize or help, improve the use and reduce confusion? And then what all could we be doing to get real world safety data? So then I'd like to raise the questions for the audience, which is, what do you think about this conceptual model? Is there any major pieces that we missed? And then is anything on there that just doesn't seem like it belongs? And what are you all working on or think are important next research directions? So I'm going to invite you to drop that in the chat if you have some immediate responses or thoughts. We'll kind of do hopefully a little bit of a moderated discussion here. So we'll do, and as well, we would like to take questions from all of you.
Great. One comment that we had in the Q&A actually addresses, I think, maybe something that she sees as missing, and that is motorized wheelchairs as another user group, and possibly future extensions of motorized wheelchairs to be used just as a convenient way for anyone to go a short distance. So not just as a mobility aid, but for everyone. So what surprised you? I guess I'll start with Rebecca, maybe, or what was unexpected when you started looking at the crash data collection, and then one of the questions that we got also had to do with kind of questioning why you chose 2011 as the break point.
Yeah, so 2010, and I did answer that one in the chat, but thanks for bringing it back up, Sue. So that was a NHTSA decision. That was not, we didn't make that bifurcation in the data. That was a variable that was predetermined. There is another way to look at age in the data set, but it's really convoluted. And with the size of our sample, it didn't make a lot of sense to spend a lot of time there. Essentially, that you can look at you can look at the model year and then crashes that are associated with the several years preceding that. So it's not really straightforward, and we didn't feel super confident using that, again, partly because of the small sample size. I do think that as these data increase in number and as ADAS features become more and more prevalent and the SIS data set grows, there will be other breakpoints. So I think if we were to do this research in 2 to 3 years, we would be able to show different things. I certainly hope we'd be able to show stronger, signals in the data for the real life outcomes. So to get to your first question, Sue, I think that was maybe the most surprising part, was that, for all of the hype of these features, the signals in the data were pretty subtle. They were there, and like I said, we did get a couple of statistically significant results, but it was, like at the 95% level. And definitely would be something where I would say more research is needed. This is promising, but at this time with that data set, and I don't know if we were really clear about when we conducted this research. It was at this point 2 years ago now. So even at this point, the SIS data set would be larger, more robust, would have more models with ADAS features. I think we'll be able to see more and more if there is a real world impact, but at the time that we looked at the data, they just weren't there.
And maybe same question for you, Tara. What surprised you or was unexpected as you started looking at this topic?
Yeah, I think, I kind of alluded to it with the police crash reports, is I was not very aware of just how the Fourth Amendment prevents, police crash reports, from getting data from the vehicle. And spoke with some officers at our extension service about that. And it's part of this larger issue of the way that cars operate in this weird quasi public-private space, right? So they're used on public roads as citizens we're out there interacting, and we don't get to choose like whether the person that we're interacting with is using their technology, how they're using it, whether they're, like in an autonomous vehicle or whether they're on their phone, right? There's this kind of weird space where, but the vehicle inside our vehicles are private spaces. And so I think it speaks to larger issues that we're wrestling with in our country about safety culture and approaches to safety and what we're willing to do or give up or whatever in order to make all of us safer. That without, like, I'm not saying that privacy concerns aren't real or we should do away with the Fourth Amendment or whatever, but it just seems like as technology advances, we're going to need to also have technology advances in the way that we could collect data that don't violate those, but also get us potentially better data. So I think that that's an open question that needs more exploration, but it was something that I just wasn't aware of at all before starting the study. That was really interesting.
And I think it's the case too, though, that it's not the data that are being recorded in the CAN bus don't always include the state of every ADAS system.
Right.
You're not guaranteed that you're going to know whether or not the lane departure warning was engaged or not. I remember talking with somebody from one of the car manufacturers that a lot of their people didn't know that they had those features until they went off. I mean, all of a sudden there's like, oh no, it's making this noise, And so they, it was not part of their purchase decision. It's just, it came with the leather seats.
Right. Right, exactly.
I think
And
that
oh, go ahead, Rebecca.
I was just going to say, I think that gets to your point earlier about, we're missing an opportunity with the purchase to educate people. And even, some of the research that we had reviewed for earlier in the project, and some of the other work that Tara did as part of this really does show that, the people in the dealerships don't necessarily know either. And so there are multiple levels and multiple points of education where we're missing opportunities. And, we have been talking a lot about safer vehicles. I led a workshop at TRB about, as vehicle size and mass are increasing, and that has all sorts of other negative impacts on our system and on safety, we desperately need to understand this problem. And we're just kind of like lacking the structure. And as Dr. Goddard said, also the safety culture to demand it. Some folks are seeing teen drivers as an opportunity for a pivot here because that's an area where people may be more willing to accept regulation than for themselves. But, we also still have, I just was seeing today, like half of the passenger fatalities in 2023 were people not wearing seatbelts. So we've got a long way to go in terms of safety culture for a lot of our country still. And this is just one aspect of it. I think part of our work is really trying to help clarify that ADAS is not the silver bullet, in case you were thinking it is. It's not, but it can be part of the solution.
Yeah, and I would just add to that, because I think it's really important, and it was not part of this project, but this issue of driver training and licensing and how infrequent that happens, and how in our country we've actually gotten to a lot of places, and even to do driver training for the teen drivers, like it's $1,000. So it's like people have to opt in, they have to be able to afford it. So it's an equity issue. And then also how much, are these new students getting trained on these technologies? And it's why even you see people when they get in a rental car, or if they even switch vehicles with their spouse for a couple days or something, like these technologies are in different places, they sound different, they do different things. And so without kind of any standardization, it becomes very challenging. Like you said, something goes off and they're like, something's beeping and I don't know what it is, but could be important, maybe.
It's usually beeping at a very important time.
Yeah. I do see a question. Oh, go ahead. I was going to answer that. I see a question in the Q&A about V2X. So thinking about like safety concerns, like from vehicle to the infrastructure, I think that's a great question, and it's kind of just like this, but in a bigger way, right? So now we're talking about not only these systems and how they function and get used within the the vehicle itself, but then how are they interacting? So you're just adding, I think, orders of magnitude potentially of complexity and things that need to be figured out. So we didn't study, but I agree with you very much that I think this is something that needs to be expanded out, is how and even for example, to kind of make it analogous to ours, how are these technologies or infrastructures being marketed to the places to implement them, right? So are the folks who are making some of these technologies going to a city and saying it'll do XYZ? How standardized is that information? What is it named? What is it promised? All those kind of things, I think, would just be one analogy, but a really important thing to look for going forward. And I wanted to comment, Laura, I think I got a little bit confused with your question, sorry, which is why maybe I didn't respond. But your point broadly about, we absolutely agree that there is a huge need to have better data and more focus on how these technologies interact with people outside of the vehicles. So whether it's motorized wheelchair users, analog wheelchair users, people with all different kinds of assisted devices, all these things, like there is a huge lack, I think, like Dr. Sanders pointed out about, even the data that we were able to find about how those are involved. And then certainly, there's definitely an interest in some of these technologies are being developed and being deployed as pedestrian detection and bicyclist detection. But, there's a lot of open questions about how effective are they, or do drivers over trust them and maybe not, pay as much attention. So it's a huge area that needs a focus. So thank you for raising that.
Okay, not seeing any other questions. So thank everybody for joining. This webinar recording will be uploaded to YouTube, and you'll get an email when that is complete. And then I will put a link in the chat that goes to the technical report for this. And as they mentioned, there were a couple of publications that have already come out based on this research. Our next webinar and our last webinar, because our center sadly has reached the end of its funding cycle, so we are sunsetting our center right now. But March 26th, the topic is micromobility regulation best practices. Scoop now and regulate later, presented by researchers here at Texas A&M Transportation Institute. And that is, you can register on our website, and I will also put that in the chat unless someone beat me to it.
Great. And I just want to say thank you, and feel free to reach out to us if you have any comments or feedback or questions. Our information is available through the webinar, I think, and on the project site. So.
Okay, the link to the report is out there. All right, thanks everyone. Thanks for your patience at the big bumpy start. All right, good day.